Hey everybody, this is your 1.2 calculus video. So on this section, we are combining functions, which basically means we're going to add, subtract, multiply, divide any type of function. For example, you might have a quadratic divide by a different quadratic. Or actually, let me make it a little random, because in calculus you really do have some random things sometimes. You could have two different types of functions, and then they call that combining functions. So you could have any sort of combination of things. There's also shifting, like shifting it up, shifting it down, like vertical shifts, also horizontal shifts left and right. You also have scaling graphs, which we usually just call stretch, compression, and shrink. And then there's also reflections across the x-axis and y-axis. Okay, so your objectives are algebraic combinations, compositions of functions, which is when you have things like f circle g, g circle up at h right there. You could also have f circle g circle h, like 3 of them. So you really got to pay attention to that part. Shifts, vertical and horizontal scaling, and then graphing and combining functions. So while we're studying this, is in this section we look at the many ways functions are combined or transformed to form new ones. Sum, differences, products, and quotients are all operations. Combining like terms. Pay attention to the domain of each one individually as well as the combined domain. It uses the symbol. It looks like an N. It's an upside down U. It basically means and. So P of, like, the probability of A and B happening is called intersection. It means probability that events A and B both happen. Like, both happen. So, for example, you have homework and you do it. Ha ha ha. Okay. The next one. Compare to a union, which means either one. Like, you could go out to eat or to the movies. Okay. Or you could go here or there. Okay, the graph of the function f plus g is obtained from the graphs of f and g by adding the corresponding y coordinates for f and g at each point in their domains. So, for example, you might have something random like a line and a curve, and you add this y value to this y value to make it taller. So, things like that. This says in figure 1.26, which has two square root functions. So let me pause the video and show that. Okay, so let me go back just a little bit. 1.25 looks like this. It's combining two functions. So say you have the blue function and the yellow function. Then the red one is combined, so this one plus that one is that one. And then here's your 1.26, where you have a square root of x is blue, and you have a g of x, which is yellow. And then when you do f plus g, you get the semicircle type thing up there, and the times you get it down there. So what they're showing you is two square root functions. The domain of f plus g is the intersection of the domains, the interval 0 to 1 on the x-axis where it overlaps. And this interval is also the domain of f times g. So at any rate, it could get complicated. Composite functions, this is when you have the output from one function becomes input to the second one. So you have g circle f of x. Well, that little circle doesn't mean O, it's g of f of x. So you want to work inside out like that. If x lies in the domain of g and g of x is in the domain of f, then they can be composed to form that, and the functions for f circle g and g circle f are usually quite different. The exception would be if they're inverses. Shifting a function, so the vertical shift is when it's plus k, which is outside the parentheses. A horizontal shift is when it's here, which is inside the parentheses. It's right when it's minus and left when it's plus. So those are some things you noticed from Algebra 2. Any type of function, I don't care if it's a quadratic, a rational, a square root, like anything, any type of f of x. Then for scaling and reflecting, if c is greater than 1, it's a vertical stretch where it is. So that's where c is on the outside. It compresses if it's 1 over c, compresses vertically, and then compresses horizontally as if you have c times x inside, and stretches is if it's x over c. So what you will notice is they're opposites. If it's multiplying, and if it's on the outside, it's a stretch vertically, but if it's in the inside, then it compresses horizontally. So these two words are completely different than those two words. And then the same thing here. Okay, now if it is -1, then it reflects the x if it's on the outside, and it reflects the y if it's in the inside. So this is up and down, and this is left and right. Also, random statement, odd functions are dominant. So even if you have x cubed plus 3x squared, treat it like x cubed, which would be like that one for the parent. Okay, so that's basically the notes part. Now let's do the problems. So what I did this time, what I printed it, is you have your problems, and instead of the answers being in the back, they are right here. Next time I may have these answers actually what they call in line, which is in here, because that actually may be even better. So just trying to improve all the time. So your first one, what is the domain of f? Well, you have x is basically the function, so that domain is -infinity to infinity. And the range is the same thing. So that's just simply this. So this part is your domain, and this part is your range. Now the next one, you're going 10 units to the right, and then you're going like that. So your range, well, your domain is with a bracket this time, and it's 10 infinity. The reason it's a bracket is because this little point is 10, 0. And then the other one would be, that's your domain. And then your range is from here up. And it continues going up, but it is a little bit slower than some other functions. So that would be 0, infinity. Now for the domain of f plus g, you could just type it okay, so we're going to do x plus the square root of x minus 10, enter. It's not showing up, but you might want to do zoom fit. So 4 and then a. Okay, that didn't show up either. So maybe you want to look in your table first. You see all these errors. Okay, except at 10, I actually start seeing data. See that? And so what I might have wanted to do is make this like 50 and make this 50. So there you can see it. So you're basically having, let's see, we use those two. We're doing 10 infinity for both. So in other words, it's x greater than or equal to 10 and y greater than or equal to 10. So when we went into our table, 10 was the first x, 10 was also the first y. So anything to the right of 10, including 10, and anything at 10 or higher. So they are at different rates because of the square root. Then you have the one with times. What I have been doing just then is I use these two, I use these two, I use these two. These are the last two, and they're with times. So then what I do is I get rid of my table, and I delete this, and I'm going to put parentheses around that. Notice when you open a parentheses, then it closes it in the back. Now this one says cannot accept change. Oh, I remember whenever you see this error, that you have to put the little time sign first, I think, like that. Yeah. Notice what I did. I had to use the little time sign to put a dot in between. So that'd be your hint. Type x times the square root of x minus 10, or get cannot accept change. Error. Okay. So then when we look at our domain, it looks like it's from that point on to the right and from 0 up. So let's look in our table. Okay, so 10, 0. And so that'd be our point. And so that's 10 to infinity. And then this one is 0, infinity. Okay, so there's number one. Yes, there's lots of parts, but it wasn't that hard. Okay, on this one's telling you go left 7, and this one's going right 6. So that means you're going to be at -7 infinity and at 0 infinity, because that part is basically a square root function that looks like that. And for the g function, you're going right 6, so it's going to be like that. So then you're going 6 infinity and 0 infinity. It really does help with repetition. Remember the parent function, and whether, plus means left and minus means right. Okay, now we're going to do f plus g, and so that'd be the square root of x plus 7 plus the square root of x minus 6. So that's what we've got to put in our calculator. Square root x plus 7, go outside it, like to the right, then plus the square root of x minus 6. If you forget, it'll just look weird, like nested square roots, like one on top of the other. Okay, so there's our graph. We need to find that point. So if we look in our table, it looks like 6 has a number. So from 6 on, and then on this one for the range, think that it's 3.60555 for a reason. The easiest way, because there's no convert to a square root button, you can just use the numbers and say 6 plus 7 is 13. I wonder what the square root of 13 is. So if you go to the square root of 13, control enter, sure enough you see that. It's 3.6055 and so on. Notice the numbers kept going, just like over here. Down below, the numbers kept going. So that's going to be what you want. So that would be square root of 13, comma, infinity. Okay. And then for times. Okay, so now what's a little different on this one is if you're saying square root of x plus 7 times the square root of x minus 6, when you multiply them, you're going to get something different. It's no longer going to be a square root function. I guess you don't actually have to write it out, you just have to say what the domain is. So what we want is square root of x plus 7 times the square root x minus 6. And so it looks like that. And this one, you look in your table and find your first value at 60. So if it's 60, that means this part is going to be the 6. So bracket 6 infinity, and the 0 would be 0 infinity. Okay, so there's a couple of them. Yeah, they have lots of parts. Okay, now this one does also. You have f of x equal 3, which is a horizontal line. And for g, you have a quadratic. Find the domains and ranges of the two basic ones, and then f over g, and then with g over f. So again, this has a lot of choices too. For the 3, it's just going to be the horizontal line, and so that domain is negative infinity to infinity. And the range is the one that says list of values, and it would just be 3. Okay. So the next part would be the parabola. Okay, so that's for 3. Now that's for those two. If you want to block it off like that, you can. Okay, now we have the next one, and so those two go together, and that's x squared plus 2, so that's going to be like that. So that domain is all real numbers, so negative infinity, infinity, and that range would be from 2 up, so bracket 2 comma infinity. So to infinity and beyond. Okay, next. Now we have f over g. So this is where you go 3 on top and x squared plus 2 on bottom. Now, what we know about when it's like 1 over x squared, it would be like that when both things are up, instead of 1 up and 1 down. Okay, so let's see how that affects that. Okay, so we're going to go to a document, and we're going to go to 3 divide by parentheses x squared plus 2. Okay, so when you do that, it makes a little bump. So when it's 3 over x squared plus 2, it has a little bump and goes down. Now, it's not exactly at 2. If you go in your table, you'll see 0 is 1.5. And the other way to write 1.5 is 3 over 2. Now notice in our fraction we had 3 over 2 like that. And so that will be a big hint for how you do that. Okay, so for our domain, it's all real numbers. And for our range, it's going to start at 0 but not include it. And then it's going to go up to 3.2. So that's going to be 0 in parentheses and then 3 halves as a bracket. Okay, now we have to go the other way, and so this time x squared plus 2 is on top, and then 3 is on bottom. So this time we have, okay, so this time we have x squared plus 2 on top and 3 on bottom. Okay, so delete some of this. X squared plus 2 and then divide by 3. Okay, well that's just like that. So that's a parabola. Let's actually look for our vertex. Whoops, I hit escape. I didn't know it could do that. It removed what I previously typed. Okay, x squared plus 2 and then divide by 3. Okay, so there you go. Okay, so this one we're going to do the minimum from here to here, which is 0, and then it says 0.6 repeat. By the way, if you see the extra 86, just ignore that. In fact, let me try something. I know I've preached like use 12 decimal places, but I'm going to change it this year. What if we just use 9? I wonder if that makes it better. No. Well, let me try one more time, because it might have to refresh. X squared plus 2 over 3, and then menu, analyze, minimum between here and here. Yeah, it still gave me the 86 at the end of all those 6s. But you have to just treat that like 2/3. So if you didn't know that, you go point, and then you have to type halfway, and then do menu number fraction. So there's your 2/3. Now, how else could you remember 2/3 from this? So your numbers are in the problem. So our domain is as wide as you want, which is all real numbers, and our range is from 2/3 up. So domain is -infinity to infinity, and range is bracket 2/3, comma, infinity. Whoops, I put that in the wrong spot. The range is bracket 2/3, comma, infinity. Okay, so there's the first few. Now we have some more. Okay, so on ones like this, you have to work your way inside out. And do g of 0 first. So that means you go 0 squared minus 2 is -2. And then do f of that answer, which is the answer. And then you get 2 plus 3 is 5. Oops. G of 0 is -2. F of -2. Oh, I went to the wrong thing. It was -2. If it's -2 plus 3, that's really 1. So that's your answer. So watch out for sign mistakes like that. On this one, we have to do f of 0. So you go to the f function and do 0 plus 3 to get 3. Then do g of 3, and you do 3 squared minus 2. 9 minus 2 is 7. Okay. Now for f of g of x, there's not going to be a number answer. You basically start writing the f function. So for example, it's going to be something plus 3, and then you plug in x squared minus 2. So this is the g, and the whole thing was the f. Now you have to combine it, and so that would be x squared minus 2 plus 3 is 1. So you get x squared plus 1. Okay? So it was f on the outside, and so it's going to be something plus 3. And then we had to go from there. Okay, on the next one we're doing g of f of x. So start writing the g function. So that's going to be something squared minus 2, and then plug in the f function there, which is x plus 3. Put parentheses around it. Now, unfortunately, they want you to expand it to combine your like terms, so that's where you got to do FOIL. And so you do x squared plus 2 times 3x plus 9, which is x squared plus 6x plus 9. Now, you also have to do your minus 2 to the back, and so that's going to be x squared plus 6x plus 9. 9 minus 2, 7. 7. Okay. Okay, so now we're doing f of -5. So first you do f of -5, which would be -5 plus 3, which gives you -2. Think of it as you're starting at -5 on the number line and then going right 3, so you end up at -2. Now we have to do f of that answer, and so that would be 2 plus 3, which is 5. Oh, again, here's a negative, put the negative here, negative there, and this is a 1. Okay, my bad. Okay, then this one we're doing g of 3. So you can say 3 squared minus 2, so 9 minus 2 is 7. And since we're doing g of g, you have to do g of 7, which would be 7 squared minus 2. 49 minus 2 is 47. Okay, now you're doing f of x. So for that one, you start writing the f function, so it's something plus 3, and then you got to put x plus 3 in here. So you end up with x plus 6. Okay, and then for your g of g, we go something squared minus 2, and then we do x squared minus 2 right there. Now on this one you have to expand it as well, because you see this is going to be the answer. So we have to do x squared squared is x to the 4th minus 2 times the first term times the second term, and then plus 4, and then bring the minus 2. Okay, so this is a plus 2, sorry. Okay, your first term, when we say plus 2 of each of these, that's why this is a plus. So we get x to the 4th minus 4x squared plus, these are like terms, 4 minus 2 is 2. So that'd be your answer. X to the 4th minus 4x squared plus 2. Okay, and on number 7, this time we have F circle G circle H, and we're basically going this direction from right to left, like inside out. And so we want to start writing F, which is something plus 2. So that's the F level. And then on the G part, we're putting 3x. So that's going to be 3 times something else plus 2. And then on the H level, we've got to say 3 parentheses 5 minus x, and then plus 2. And let's see how that works out. We get 15 minus 3x plus 2. So that's 17 minus 3x, and that's the answer. Okay. This next one may take a little bit longer. Yeah. Okay. I've got to stop right there because I have a meeting, but at least that's the first video. Hope that helps.